Good morning, everyone. My name is Avat Shekoofa. I'm a crop physiologist working with the University of Tennessee here in our location in Jackson. So today we're going to talk with you a little bit about cotton water management, and we're going to show you different scenarios that we created for evaluating the environmental impact on cotton growth and development when we have different rate of soil water availability. Here you can see our cotton plants, different cultivars of cotton under a situation that I call it extreme environment. We have a rainout shelter that when our cotton plants, they almost more than 85% cover the canopy was closed, closer to early square. We moved this rainout shelter over the field that was planted earlier. So since then there is no rain, no irrigation here, and we wanna see the potential, the physiological responses of these four cultivars and see how they are different in their physiological responses. So as you see here, you can clearly see the situation, the wilting that is happening here, the color changing due to the amount of stress that we have here. But still, there are different situations among cultivars when you look at them. And then the interesting thing is, if we walk out of this place and go to the rain-fed plot and looking at the same cultivars under rain-fed, you can see almost a different situation. The same story with the irrigated plot, that they are a little bit further away from our rain-fed plots. It's very interesting how the rate of wilting is different in this condition that we call it extreme versus rain-fed and irrigated plots. So if you look at here, you see these plants are wilted to the stage that they created a huge gap in a row spacing. The row spacing that you will see between these cottons and plants and the one under rain-fed and irrigated are the same. But because of wilting, not only we are losing water through the plant, through transpiration, we have water loss through evaporation from the soil, right? And this is very important. So in this condition, I told you about the environmental impact, but then the cultivars are very important. We're looking for those that they are not wilted too much. Why? Because the one that they are not wilted, they have a better coverage on the soil and they survive to use more water that they saved earlier in the season with lowering down the transpiration, now less wilting and using that water that they saved. So cultivar selection is another important thing when it comes to abiotic stresses or environmental impact. Here in this slide, I wanted to show all of you almost what you see behind these slides and behind these poster boards, which is our rain-fed plots versus our rain-out shelter plots and our irrigated one. So this slide is showing something very cool here, and that's the impact of drought. You see how the plants in the left sides are wilted, and the right, the rate of wilting is way different under the shelter that is extreme condition versus rain-fed, and in the middle it's the irrigated plot. You see, in this plot it's very good. The plants are growing well, no sign of wilting, and the soil is covered and shaded and with the leaves and plants. So we have very limited amount of water loss here versus in these two conditions, evaporation from the soil. So this is something that I wanted to show you guys. And then I wanted to show you how cotton cultivars are different in their wilting score that earlier we were talking about. Actually, this picture, this slide completely covers what I was going to show you. And you see this one on the left is extremely turgid, nice, no wilting. And look at here. So why this is important? This is important earlier in the season. We have the cultivar of cotton that can save water, that can reduce the amount of water loss, and has still water left in the soil. It's that simple versus this one here. So which is gonna impact later on if we have a condition like this year with more wilting, more drought condition with yield, with production, which I will show you a few slides covering this topic later. So here, ta-da! It's very interesting looking at this fluctuation that we keep talking about rainfall and temperature, and how variable is that? Look at this. This slide is showing 2017, 18, 19, and 20 in our field in Jackson. And each month from May to August, you can look at the change in rate of rainfall. Just as an example, July 2019 versus 2020 or 2017. Or you can look at the months of August, from August 1st to 12th, and look at the rainfall amount that we had. It's not only rainfall, just look at this area. How much temperature increase and heat we had in July 2020. We're on top of the over average range of temperature for the months of July in 2020 and as well as in 2019. So it is very important to be aware of this environmental impact. Our goal was to look at to observe our cotton growth and development when we have different irrigation management in the field. In one of our field here on the station in Jackson, we applied irrigation, rain-fed, and for irrigation, based on previous year study, we decided to cut fully irrigated mound, which we were applying irrigation even earlier in square or later higher amount in early bloom and late bloom. But we noticed the best outcome for cotton production in our silt loam soil and under the environment that we have experienced in 2017 and 18 was semi or reduced irrigation, which we started irrigating cotton per week, 0.5 inches from bloom to late bloom and late bloom to crack bowl, like later on to 1 inch. So what is this third item is talking about? It's talking about using technology that we call it sensor, soil water sensor, soil water loggers, and irrigating our cotton field based on that. So we follow the same pattern of semi-irrigation, but in that case we hold water an application of irrigation until we see negative 70 to negative 80 kilopascal water holding water potential and water tension is applied, and then there's a need to apply irrigation at bloom to late bloom and late bloom to open bowl at this rate that you see here. So let's see how these loggers and sensors are working. I'm not gonna walk you through details of that, but I just want to have you looking at this slide to see behind us you can find one of these loggers, and then the rain gauge, digital rain gauge that we use, and the access, online access. I just took a screenshot and left it here for you all to see. Simply you can have access to your field and soil information in your field using your phone. And then here we wanted to show you what you see here is a portion of July to August, and this is the metric potential kilopascal water in the soil and the amount of precipitation based on rainfall or water that we put on, like extra water as irrigation we applied. And these two lines, two graphs are showing the tension of like soil that is holding water, the water potential, and the moment that is dropping, the combination of these two sensors dropping to lower negative amount, the more negative, so it's gonna hit that question, we're ready, we need to apply irrigation, put that amount of water available back to the normal. And you see this fluctuation because of dry environment, and we were able each week to apply that water and put that back to field capacity. That's helping with better water availability for plant to uptake. Here, just want to show you that we tried in these past few years, and we're working on it still, testing different cotton cultivars in the field, starting with 6 cultivars into going up to 11, 12 cultivars, introduced the, whatever cultivar was introduced to us, new cultivar of cotton, we tested those in the field to see how they are, the physiological activity of these cotton plants are different or not under different water availability, under stress, under rainout shelter. So why it's important, again, goes back to the physiology of plant and the amount of water loss under environment. So what we are looking for is cultivars that they don't transpire a lot, they hold more water in the soil, and by the end we have more water available there, and we'll see how that's going to impact on yield. And it is a very environmental related. This, if we have a drier year, probably it's going to help better with yield improvement versus a year that is a extreme wet year. So the other thing that we considered starting doing the experiment in the field in 2020, and all of this research based in previous year were funded and supported by Cotton Incorporated instead of Tennessee, which we really appreciate that, is adding a thermal system, thermal imaging, using an unmanned system in the field. Why we recommend this? So the transpiration and water loss that I described to you all is related to temperature of that canopy. So the hypothesis is if these cotton plants are cooling down via transpiration, there might be different temperature rate in each one of these cotton cultivar in the field. So that was interesting if we could capture that, while we already know based on their physiology, some of them they save more water, they transpire less, some transpire more. So can we see that in temperature based information for them and how that's going to help us? You know, to screen these many cotton cultivars, we need too much time using all the technique, physiological measurement, equipment that from the ground. It's very difficult. What if we can use this technique and cover many cotton cultivars and then check the temperature and screen them based on that? The other thing is, what if that technique can help us with better irrigation decision in the near future? So what we accomplish, what we have achieved during these few years of study. So as you remember, I talked about diverse responses of cultivars, right? Here is an example, and what we noticed, this is an example of one phytogen cultivar versus a sunbill that we had, and here you can see the years of study and cotton lint yield here on the y-axis. So in 2017, significant yield improvement in a phytogen cultivar versus sunbill. You see here in August how turgid is cotton cultivar from phytogen and how wilted is our sunbill line. This was very interesting to notice. This is an important parameter, an important trait that works in a drier year much better than wet year, because in a wet year we still had a better yield but not statistically significant changes between our cultivars. So while cotton over the world, more than 58% of it is rain-fed, and in the US over 60% rain-fed, and also in our area almost 92% of it rain-fed. So selecting cultivars can be a very important task. And the other thing is, we don't have too many choices to deal with this challenge. We have irrigation, selection of different irrigation structure, or cultivar selecting to help us with yield improvement. So this slide actually is talking about irrigation 2017, 18, 2019, y-axis you have yield. You see, we didn't get any better result applying too much water earlier from square time, when that's what our fully irrigated was covering. So we decided that the best choice for our soil and our environment, based on the result that you see here, is semi-irrigation. Actually in 2018 and 19, that we had plenty of rainfall, the soil was at filled capacity, we even didn't see much of change based on semi. So yield is very related to that rainfall amount in the field too. So what we accomplished in 2020 based on our thermal imaging. So this work is in process. We still have our cotton in the field. But I wanted to show you this because it's very exciting. This is one of our irrigation system, our irrigation pattern, and I just want to show you a few plots here with a few cultivars. On the top you see before irrigation, on below you can see like after irrigation here. So you clearly can see temperature changes before and after. We found between 2.6 to 3 degrees Celsius cooling down the temperature after irrigation. And the other extremely interesting thing is the temperature base between cultivar. Here E7 versus E10. E10 is much cooler, even more than 6 degrees Celsius cooler than E7. So this is very interesting, and we're really excited about analyzing data and looking at the replications of these in the field and coming up with the understanding of screening 11 cultivars for different temperature rate. So hopefully we're gonna have data to share with you in 2021. So question that we still have, and we're gonna pursue this and we're gonna find out how we can deal with it, is the environmental impact is there and we still see the fluctuation of rainfall, and we're like, while we're trying to take this video, we went through different scenarios from a very dry, hot rain, and then now we're under cloudy situation, continuing taking this video. So we need to irrigate sometimes, and sometimes we have the rain-fed conditions. And you know, cotton growth and development is very, like the structure of cotton, the architecture of this plant is very important under both this environment, how we manage that. One thing that makes this more complicated is the PGR application, which cotton is does need that. Like cotton plants, they need to receive PGR such as pigs to manage the height of plant, to manage the vegetative growth of cotton, while we want to have better yield, better lint quality. So how can we manage this under different water management that we have in the field? Why we're talking about water management for this PGR pigs application? Because PGR application pigs, for example, is very related to environmental factors such as water, soil, heat, also developmental stages, and cultivar genetics, which we keep discussing all of these items. And as you see here, the application of this PGR can change the internode lengths, can change the architecture of plant, and we are going to get rid of all this vegetative part to have better cotton ball and more production of yield. So this is the challenge. If we have higher rainfall, more irrigation during season, less, or we have rain-fed conditions, what can we do? How we can adjust this? Also, to make this a little bit more complicated, I want to show you that cultivars are different. Some of them are very growing aggressively, some of them passive. So some of them, they have huge vegetative growth, and we have to control them with pigs much better. But what if we are under rain-fed conditions? Oh no. What if it's an irrigated plot? So how can we manage that? And what time of the year is the best that we can manage these two different quality of growth under water availability? So to answer this, we're gonna do this set of experiment in 2021. We're gonna consider our main goal is have the environment that we have stress, and then the environment that we manage water. So if we're on well water condition versus rain-fed conditions, and then we're gonna try to apply peaks in different rate at low, mild, and high. And while we have different cultivars, when we already have access to their physiological parameters and information. So we're gonna change the amount break the amount and apply from low to high under both water availability and stress. Then we're gonna look at the architecture of plant and see how this cultivar and the rate of from being aggressive to passive, how that is changing under both conditions of stress and well water.